The ocean world of K2-18b. Could it harbor alien life? Imagine a world shrouded in a hazy blue atmosphere, orbiting a dim red sun in the vast cosmic darkness. This is the exoplanet K2-18b, a colossal sphere, approximately 8.6 times more massive than Earth, revolving around its star within the habitable zone. Its skies contain traces of water vapor and possibly even gases that could be associated with biological activity. K2-18b has rapidly become one of the most fascinating and mysterious worlds ever discovered beyond our solar system. K2-18b was first discovered in 2015 by NASA's Kepler Space Telescope during its K2 mission. Astronomers detected the planet as a faint dip in starlight while it passed in front of its host star. The star, K2-18, is a cool red dwarf located in the constellation Leo, approximately 124 light-years away from Earth. By analyzing the transit data, scientists identified K2-18b as a sub-Neptune-sized exoplanet, larger than Earth but smaller than Neptune, a type of planet not found in our own solar system. Follow-up observations soon revealed more about this alien world. K2-18b turned out to be about 2.6 times the size of Earth, and nearly 8 to 9 times more massive, making it what scientists call a super-Earth, or a mini-Neptune. It orbits its small red dwarf star at a distance of just 0.14 astronomical units and completes a full orbit, or what we'd call a year, in only 33 days. What's more fascinating is that this orbit places K2-18b right in the star's habitable zone, the so-called Goldilocks zone, where conditions might be just right for liquid water to exist. In fact, it receives nearly the same amount of light from its faint red star as Earth does from our Sun. That's why it became a key target in the search for potentially habitable worlds. To better understand K2-18b, let's look at its key characteristics as scientists have uncovered so far. K2-18b has approximately 8.6 times the mass of Earth and a radius 2.6 times larger. Despite its large size, its relatively low density, approximately 2.7 grams per cubic centimeter, suggests that it's not a solid rocky planet like Earth. Instead, it likely possesses a thick atmosphere or possibly oceanic layers beneath its surface. K2-18b orbits a cool red dwarf star every 33 days, much closer than Earth orbits the Sun. But because the star is so dim, it still falls right inside the habitable zone, where liquid water might exist, either on the surface or hidden deep below. K2-18b's estimated equilibrium temperature is around 265 Kelvin, approximately -8 degrees Celsius. However, if the planet has a thick atmosphere, greenhouse warming could raise the actual surface or cloud top temperatures significantly. The gravity on K2-18b is about 1.3 times stronger than Earth's, meaning you would feel slightly heavier, but not crushed. You could still stand and walk on this alien world. The K2-18 star also hosts a second, smaller planet, K2-18c, which orbits closer to the star on a tight 9-day cycle. Due to its proximity, K2-18c is likely too hot to be habitable. K2-18b, however, remains the true star of the system, both literally and figuratively, for those searching for another Earth. What truly sets K2-18b apart is what's in its atmosphere. In 2019, researchers using the Hubble Space Telescope made a groundbreaking discovery. They detected water vapor in K2-18b's atmosphere. It was the first time water had ever been detected on an exoplanet located within the habitable zone, instantly making K2-18b the only known super-Earth to host both water and temperatures that could support life. These findings suggested that K2-18b may be surrounded by a thick, hydrogen-rich atmosphere with clouds of water vapor, possibly covering a vast ocean beneath its gaseous layers. This intriguing discovery sparked deeper investigation into K2-18b's atmosphere. In 2023, NASA's James Webb Space Telescope, JWST, turned its focus to the planet and uncovered even more of its atmospheric secrets. Webb's infrared spectroscopy revealed an abundance of methane, CH4, and carbon dioxide, CO2, in the atmosphere. In contrast, ammonia, NH3, appeared to be notably scarce. This molecular composition closely resembles the profile of a theoretical Haitian world, a planet with a hydrogen-rich atmosphere layered above a global liquid water ocean. The strong presence of methane and carbon dioxide, combined with the lack of ammonia, strengthens the possibility that K2-18b could host a vast ocean beneath its thick atmosphere. One of the most electrifying discoveries came with the James Webb Telescope's initial observations in 2023. The possible detection of a molecule called dimethyl sulfide, or DMS. On Earth, this compound is produced exclusively by life, primarily by phytoplankton in our oceans. The signal was faint, just a subtle trace, but it was enough to send a wave of excitement through the scientific community. Could we be detecting the chemical footprint of life in the atmosphere of a distant world? It felt surreal. Scientists knew this was just the beginning, and that much more data would be needed to confirm what they had glimpsed. In late 2024 and early 2025, the James Webb Space Telescope team continued their observations, this time including deeper mid-infrared measurements. These new datasets further strengthened the signs of dimethyl sulfide DMS in the atmosphere of K2-18b. The spectral fingerprint of the planet's air, according to the researchers, is best explained by the presence of DMS, or a related molecule, such as dimethyl disulfide. Remarkably, the reported levels of DMS may be up to 20 times higher than those found on Earth. If confirmed, this would represent a truly groundbreaking discovery. But science demands caution. As compelling as the evidence may be, it still falls just short of the strict threshold required for a confirmed detection. The researchers remain careful in their conclusions. Further observations with Webb are planned over the next year or two to verify the findings. All signs suggest that K2-18b might be a habitable world, but not in the way we usually imagine habitability. This planet, roughly 2.6 times larger than Earth, likely doesn't have a solid surface. Many scientists believe that K2-18b could be a scaled-down version of Neptune, with inner layers of ice and vast oceans, all covered by a thick, gaseous atmosphere. If an ocean truly exists on this planet, its depth could stretch tens or even hundreds of kilometers. Above this immense body of water lies a dense atmosphere composed of hydrogen, helium, and water vapor. The planet orbits a red dwarf star, much cooler and dimmer than our Sun. As a result, sunlight at the tops of K2-18b's clouds would appear as a faint red glow. And if that light manages to reach the ocean below, the surface would exist in a state of perpetual twilight. Because K2-18b is so unlike Earth, scientists debate how habitable it truly might be. Some researchers argue that despite the comfortable temperature, the high pressures under a thick atmosphere or ocean could be hostile to life as we know it. Others point out that K2-18b might have started as an ice giant that migrated inward, potentially retaining a dense volatile envelope that is more gas than water. Essentially, a warm mini-Neptune rather than a true ocean world. In that case, there may be no solid surface or ocean surface for life to cling to, just a transition from gas to slushy ice deep down. On the other hand, the Haitian world hypothesis, championed by Dr. Niku Madhusudan, the Cambridge astronomer leading the Webb studies, suggests that planets like K2-18b could indeed host life in their oceans. Our findings underscore the importance of considering diverse habitable environments in the search for life elsewhere, Madhusudan explains. Traditionally, the search for alien life has focused on Earth twins, small rocky planets with Earth-like atmospheres. But K2-18b shows that larger water-rich worlds may offer conditions suitable for life, and crucially, their thick atmospheres are easier for telescopes to probe. In other words, nature might have more than one recipe for a habitable planet. Importantly, no one is claiming definitive proof of life on K2-18b yet. The possible biosignature gases, like DMS, are exciting, but researchers remain cautious. There are plausible non-biological sources for these molecules. For instance, recent experiments and comet studies show that chemical reactions without life can produce DMS under certain conditions. It's also possible that what Webb detected is a different molecule entirely, or a quirk of the data. Skeptical astronomers have been quick to point out the uncertainties. It is not strong evidence, one noted, regarding the current biosignature claim. The consensus is that more data and analysis are needed before shouting, "Eureka! We found life!" Still, the intrigue surrounding K2-18b's atmosphere has revitalized the field of astrobiology, offering a tantalizing maybe that scientists are eager to resolve. Could life thrive under alien skies? If K2-18b truly is an ocean world with a hydrogen-rich sky, what might life be like there? One possibility is a biosphere, similar to Earth's deep oceans. On our planet, tiny marine microbes release dimethyl sulfide gas as they process nutrients. If such microbes evolved in K2-18b's global ocean, they might be releasing DMS that rises through the thick atmosphere. Complex life, like fish or aquatic creatures, is more speculative. The environment might be too extreme, but we can imagine life adapted to high pressure and eternal twilight, perhaps gathering around hydrothermal vents on the seafloor, just like some extremophiles on Earth. The discovery of methane and carbon dioxide in K2-18b's atmosphere could hint at biological activity, though these gases can also form through geological processes. For life to survive, the planet's ocean would need a reliable energy source. Light from its red dwarf star is faint, but it might be enough for photosynthesis in the upper ocean layers. Deep below, geothermal energy could keep the waters warm. And there's time. At 2.4 billion years old, K2-18b has had more than enough of it for life to potentially emerge, if the conditions have aligned. Perhaps most encouraging of all, liquid water almost certainly exists, either in clouds or oceans. And water is the foundation for life as we know it. The real question isn't just, is there water? It's, has the chemistry clicked in just the right way to spark life? We should temper our imagination with the reminder that K2-18b is not an Earth clone. Any life there, if it exists, might be limited to microbes or simple life forms floating in the upper ocean or cloud layers. The environment could be more analogous to a high-pressure aquarium of algae and bacteria rather than a scene out of The Little Mermaid. Even so, the mere possibility of a living ecosystem on a planet so different from Earth is thrilling. It suggests life might find a way in corners of the universe we once thought were inhospitable. Let's take a journey, a mental odyssey through space. As you approach the K2-18b system, the first thing you see is a faint red star, smaller and cooler than our Sun. Orbiting around it is K2-18b. From space, it looks like a larger, bluer version of Earth, wrapped in layers of misty atmosphere. As you descend through those alien clouds, the sky takes on a reddish glow, colored by the light of its red dwarf star. Daylight here feels dim, like a never-ending sunset. The deeper you go, the thicker and warmer the air becomes. It's rich in hydrogen, maybe with traces of methane, forming a soft haze. But this air, it isn't breathable. Oxygen is scarce. To survive here, you'd need a pressure suit, a full breathing system, and a lot of courage. As you descend beneath the thick cloud deck, you might encounter rain showers of water or drifting mists of hydrocarbons. Eventually, you break through the clouds, expecting to find land. But there is none. Instead, you discover an endless cosmic ocean wrapping entirely around the planet. K2-18b's surface, if it has one, could be a vast global ocean with no continents, no islands, just deep waters stretching endlessly in all directions. Far below, immense pressure may create exotic forms of ice or a hot, dense fluid mantle. No solid seafloor like Earth's. Floating on this alien sea, under a dim, salmon-colored sky, you might glimpse a few distant stars through the cloud gaps. The red sun hangs low, never becoming blindingly bright. And perhaps, far off in the haze, a crescent shape appears in the sky. K2-18c. The gravity on K2-18b, about 1.3 g, would make every movement a struggle. Each step, every swim stroke, would weigh you down more than on Earth. Drop a tool and it wouldn't just splash. It would plunge into the water with force. Even the waves, they'd crash harder, carry more weight. And beneath those crashing waves, if life exists here, it might be unlike anything we've ever known. Maybe, if you stare long enough, you'd catch a faint flicker, a trace of bioluminescence, a sign that something is alive in this dark, endless sea. In all likelihood, any mission to K2-18b will be carried out by robots or probes, not humans, at least not in the foreseeable future. The environment is harsh, to say the least, but imagining such a journey helps us grasp just how alien this world truly is, and how fortunate we are to study it from across 120 light-years away. The story of K2-18b is still unfolding, but it marks a significant chapter in our quest to find life beyond Earth. Just a decade ago, we didn't even know this planet existed. Now, we've detected its atmosphere and even hints of possible signs of life. Kepler found the planet's shadow, Hubble found its water, Webb found carbon chemistry, and maybe even biosignatures, each discovery more dramatic than the last, fueling debate and capturing the imagination of the world. Scientists across the globe are now following K2-18b with intense focus. Powerful telescopes, advanced laboratory experiments, and new theoretical models are being applied to understand this mysterious world. In the coming years, we may finally learn whether the strange gases in its atmosphere are truly signs of life, or the result of non-living chemistry. Either outcome will be profound. If life is confirmed, it means the universe is more alive than we imagined, that even a planet so unlike Earth can support biology. But if the signals prove to be false alarms, that too teaches us, helping refine our tools and sharpen our search for life beyond Earth. Beyond K2-18b, The excitement it has sparked is paving the way for future missions. Upcoming space telescopes like NASA's Nancy Grace Roman and ESA's ARIEL will explore many more exoplanet atmospheres inspired by what Webb found here. Even bold ideas for interstellar probes and advanced sensors owe something to K2-18b for rekindling interest in ocean worlds. We now stand at the shoreline of a vast cosmic ocean, peering into the void, catching the spray of distant waves. Whether or not K2-18b hosts life, it has already taught us something extraordinary, that nature's imagination is far greater than our own. A planet with skies of water and methane, seas with no shores, and maybe even life, unlike anything we know. K2-18b challenges us to expand our definition of habitability and to keep searching the stars with wonder. The universe is vast and mysterious, but with every discovery like this, we take one step closer to answering the question, are we alone? And maybe, just maybe, on a quiet alien ocean beneath a red sun, the answer awaits.